In this video, we're going to review some of the mathematical techniques that we're going to be using a lot in a typical introductory microeconomics class. In economics, you're going to find that we do a lot of graphing, a lot of thinking about what's going on in the graph. So it's never enough just to be able to graph a line. We have to be able to get into the graph, kind of step in there, and really understand what's going on. What are the relationships between various lines? Another thing we need to spend a lot of time talking about in economics are the slopes of lines. So we're going to be thinking about that in detail as well. And then at the end, we're going to calculate percentage changes. And I'm going to introduce you to a new way of calculating a percentage change that economists use in some special circumstances. So the first thing we need to talk about is, what's the equation of a line? Let's review that idea. Now, you probably remember that you can write the equation of a line this way: y equals mx plus b. And think, what does the y stand for, right? We want to go into this very deeply. What does the y stand for? Why do we write that down? Well, the y just stands for, what is it that we're representing on the y-axis? So it's a number that's going to appear on the y-axis. What's the m in this equation stand for? It's the slope. What is a slope, though? It's not enough to know that m is the slope, but what is a slope? Well, the response you're probably going to give me here is slope is rise over run. Okay, but we've got to dig deeper than that. What does rise mean? What does run mean? And why are we interested in knowing the ratio of rise divided by run? What the slope tells us is how one thing changes every time something else changes by 1. That's what that ratio is always going to tell us. And we'll think about this a lot more during this video. X is just, what are we representing on the x-axis? And what's the B stand for? All right, you probably remember that that stands for the Y-intercept. But tell me, what exactly does that number B tell us? What is a Y-intercept? A Y-intercept tells you the value of y when x equals 0. So let's apply these ideas, carefully thinking about everything we're doing as we go along. So what we're going to do is graph two equations and then think very carefully about what's going on here. Economists, for some reason, instead of writing the equation of a line y equals mx plus b, we normally write it as y equals b plus mx. All we're doing is switching the order. We put the y-intercept first generally, and then the slope times x second. You can always tell which one is the slope because it's going to be the one that's multiplied by x. Okay, so we don't do it to be confusing. It's just the way we do things normally. If you're more comfortable switching them around, then okay, write it down the other way and switch it around. So in this equation here, I've written y equals 19 minus 2x. So the 19 is the y-intercept, the minus 2 is the slope, and x is whatever we're putting on the x-axis. Now, let me go ahead and tell you that in most graphs, not all graphs in this class, but in most graphs in this class, what we're going to be putting on the y-axis is actually the price. So let's look at this axis down here. So we're usually going to be putting price on the y-axis, and we're usually going to be putting the quantity of something. How many of something are we producing, or how many of something are we buying or selling on the x-axis? So let me write Q down here by the x-axis, but I'll write X too, just to help us remember. The x-axis down here, we usually call that the x-axis or the horizontal axis. Horizontal just means it's like the horizon as you look out in the distance. And this is the vertical axis, the y-axis up here. So let's rewrite this equation so that we can think about what it might mean. In economics, we always do applied math. That means that we're not solving for the answer and then we're done. That's what you do in a math class typically. In economics, you solve for the answer and you're just getting started. So you want to be able to really explain what you've done. So to help us explain it, let's rewrite this equation. Instead of writing y, let's write p, and that's price of something, equals 19 minus 2 times the quantity. So Q is standing in for X and P is standing in for Y. Again, we're not doing this to make it more complicated. We're doing it to help us constantly think about what we're doing and why we're doing it. All right, after all that, let's graph that equation. 19 is the y-intercept. Now again, the y-intercept tells us what the value of the y variable is going to be when the x variable is equal to 0. Now you can see that mathematically by just plug in 0 for this q here. Well, if we plug in 2 times 0, that's going to go away over there, right? And we're just going to be left with the price is equal to 19. So if q equals 0, p equals 19. So we know that this green point here is a point on this line. Now, how can we graph the rest of the line? There are lots of options. One way is just to make sure you really understand what a slope means, that the slope of minus 2 tells us rise over run, and that rise is how much up or down we're going. So how much up or down. Rise is a change in a price. Run is a change in a quantity going left or right here. So that minus 2, if you want to really understand this, rewrite that minus 2 this way. Minus 2 equals minus 2 rise divided by 1 run. We know when we divide something by 1, it doesn't change it, right? So minus 2 divided by 1 is just the same as minus 2, but we can think about it as a ratio now. That rise divided by run is minus 2 over 1. So that means that in order to get additional points for this graph, we can go down 2 to 17 and then over 1, right? Down 2 over 1. The down 2 is minus 2. The over 1 is plus 1. And we can keep doing that. Down 2 over 1. Down 2 over 1. Or some people are more comfortable making a little table to graph. So that's fine. We could say, well, here are some y values, here are some x values, or here are some p's, here are some q's. We already saw that if x is 0 or q is 0, price is 19. We could plug in some other values. We only really need 2 points and then draw a straight line through it. However, in practice, you probably want to do more than 2 points, or at least make sure that the 2 points are pretty far apart. So if you're graphing this by hand, you want to make sure that your line is perfectly straight so that you don't get misled about various points on the line. So you want to make sure you know exactly where this line is going. So let's pick a point, a quantity that is a little higher. You know, maybe 5 or 6 or 7. It's not really important what we pick, but pick a point that's far enough from that initial point over there of 19 and 0 to where we can get a really good feel for what this line really looks like. So let's choose, say, 7. Let's say, what if x, or what if the quantity was 7? Plug that into our equation here. 19 minus 2 times 7. 19 minus 14 is 5. So when the quantity is 7, the price must be $5. Now, take your ruler or something that's straight, the side of a calculator or a phone, and see what this line looks like. All right, there we go. Now let's graph this other line. Y equals 2 plus x. Well, let's go ahead and rewrite it the same way we did the other one. As P equals 2 plus Q. So what's the y-intercept of this line? It's the 2. And what's the slope of this line? It's 1. We don't see the 1, but we don't have to write the 1 when it's just 1 times Q. What is that? Y-intercept tell us? Well, it tells us that when Q is 0, price equals 2 plus 0. So this purple point is 1 point on the line. And the 1 being the slope tells us that the rise over the run is not 2 over 1, it's 1 over 1, and it's positive 1 over 1. So that says that to get more points on this line, we can go up 1 over 1, up 1 over 1, up 1 over 1. Or we could plug in a value for Q, say 10, and we would get that the price is 2 plus 10, or 12. So when Q equals 10, price equals 12, we know this is a point that must be on our line. All right, so let's carefully draw a line through those points. And let's label these equations. So this purple one is equation 2. The red line is equation 1 to help us when we answer some questions coming up. So here are some interesting questions to get us to think about not just graphing a line and then we're done, but let's really think about some of the things that are going on inside this graph. So suppose x was 4. Let's carefully think about what the implications and all the things going on if somebody came up and told us that x was 4. Let's draw a line where x equals 4 here, just straight up. That will help focus our attention on what's going on when x, or in other words, quantity, equals 4. So the first question says, suppose that somebody told us that the quantity was 4. Suppose we were concerning ourselves with equation 1, the red line. What would the value of y be? In other words, suppose somebody was selling 4 units of something, and we wanted to focus on equation 1, what is the price going to be? A couple of ways we can answer this. And I encourage you always to do it both ways. We can look at the graph and see here that on equation 1, the graph looks like the price would be about 11 over here. But the second way, and this is why we need equations and also graphs, we can use the equation and the graph to double check what we're doing. Very often you'll draw a line, you'll draw a graph, and maybe you made a mistake drawing the graph. Or you'll plug a number into an equation and you'll make a mistake. If you always use the graph and the equation together, it's harder to make a mistake because the graph and the equation are going to be trying to point you toward the same answer. And if they're not, you can figure out what your problem is. So let's use that equation. Equation 1 again was price equals 19 minus 2q. So price equals 19 minus 2 times quantity is 4. Sure enough, that gives us $11. So the math and the graph agree. We can have some confidence in the result that we just got there. Now suppose instead we were looking at equation 2. What is equation 2 trying to tell us about what's going on in the world? Well, if we look at the graph, this blue point suggests that the price would be $6 or 6 euros if the quantity was 4. Let's check the equation though. Price equals 2 plus q equals, yes, it checks out, $6. So now let's look at both lines together. And let's make up a little story to go along with what we're talking about. So suppose equation 1 tells us something about how much people are willing to pay for this product. That $11 would tell us something about how much people are willing to pay. The purple line, equation 2, might tell us something about the cost of producing these goods. So what if we're producing 4 units? And we see that people are willing to pay 11, and it's costing us $6. Many times on a graph like this, we'll want to look at the distance between those 2 points. People are willing to pay 11. It costs us 6. What's the difference between these 2 points? So again, there's kind of 2 ways to approach this. One is, if you're a visual person, you can say, well, this point here is at 11. If we count down 1, 2, 3, 4, 5, the difference is $5. That helps us visualize that difference, how large it is. Of course, another way to do it is to simply use math. 11 minus 6 is $5. So that's what I'm going for with these last question here. In problem 2, draw a vertical line at x equals 4 to help us visualize this. What is the distance on the y-axis between equation 1 and equation 2? So again, we can visualize it on the graph. We can also just calculate it, 11 minus 6, and get $5. And we want to think about what that means. Now again, we don't have a lot of context here in this situation. If that red line says something about how much people are willing to pay, and the blue line, or purple line, says something about our costs, then there's a $5 difference in what we can sell this for, what people are willing to pay for it, and what it costs us to produce it. So that $5 difference would be a good thing, right? All right, let's think about looking at this a little bit different way. What if instead of someone telling us that we're interested in focusing on this quantity of 4, what if instead somebody told us y equals 14, or the price equals $14? And we wanted to be able to tell someone everything we can learn about what's going on if the price is $14. Let's go up and look at our graph. And let's draw that line at a price of $14. So here's $14 on the y-axis. And let's draw, say, a green line all the way across here at $14. And we'll see what we can learn. So what if we were interested in looking at equation 2? Well, at a price of $14, we can look down here at the x-axis, or the quantity axis, and we can see that if the price was $14, equation 2 would be suggesting that Q should be around 12. However, what if we were interested in looking at equation 1? And what does equation 1 tell us is going on at a price of $14? Well, this orange point over to the left suggests that at a price of $14, if we follow that all the way down, suggests a quantity somewhere between 2 and 3. So the graph can help us understand what's going on here, but of course we can also use the equations. I'm pretty sure from looking at the graph that this point, we'll call it B, really is at a price of $14 and a quantity of 12. Point over here, A, somewhere between 2 and 3. We could guess it's 2.5. Maybe it is, maybe it isn't. But perhaps we should double check by using the equation. So again, that equation, number 1, is price equals 19 minus 2Q. So let's write that equation over here. Price equals 19 minus 2Q. And in this example, we're told that the price equals $14. So instead of just writing P, we know P is supposed to be $14 in this scenario. Let's write 14 there. So if 14 equals 19 minus 2Q, let's solve that. This is why you've had all those algebra classes your whole life, for this very moment. Solve that for Q, and let's see what that answer is precisely. So we'd probably want to subtract 19 from both sides, and 14 minus 19 is minus 5, equals minus 2Q. Let's multiply both sides by -1, so we get rid of the minus sign. And now what are we going to do? Divide both sides by 2, that's right. So Q is equal to 5 over 2, which is 2.5. Okay, so our guess from the graph there that the quantity down here is 2.5 was correct. But we don't want to just go on hunches and guesses. If we have an equation and our graph isn't perfectly clear to us, always do the math. It's not that hard, it doesn't take that long. So we learned in equation 1, if y is 14, that the quantity is going to be 2.5. And if y is 14, or the price is 14, that equation 2 is going to suggest the quantity would be about 12. So let's look at that horizontal line there. What's the distance between those 2 points, A and B? Well, we can start at B and count back. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So graphically, we're seeing the answer should be about 9.5. What about if we use math instead? 12 minus 2.5 equals 9.5. We get the same answer both ways. And we don't have to do it both ways, but if we're ever in doubt, we can do it both ways, and we can be very sure of our answer. Let's talk about what this might mean. We're talking about two quantities, right? According to one equation, we might be producing a quantity of 2.5 gallons of gasoline. In the other situation, we might be talking about 12 gallons of gasoline, or 12 million units, and this might be 2.5 million units. What's the difference? 9.5 million units. What might this mean? Well, let me tell you a little story of what we might be looking at here. Suppose quantity A over here told us that people want to buy 2.5 million units. However, over here at B, this is telling us that for whatever reason we're producing 12 million units. Now, if we're producing 12 million units and people are only purchasing 2.5 million units, that means we're going to have 9.5 million that we're not going to be able to sell. And that might be a big problem. So this is giving you some intuition, just some initial practice of some of the kinds of ways we're going to use mathematics and graphing, always thinking about what everything means in a graph. Now, as you see, by the time we are done with a graph, it's pretty messy. We've got all kinds of lines going everywhere, and this is why it's going to be essential for you when you're taking a microeconomics class to have a ruler, to have some different colored pencils, and to try to graph things carefully. And after we graph, we're going to be thinking about what's going on in this graph many, many different ways. Now, one other thing we're going to be doing quite often is look to see where lines cross. So problem number 4 here says, let's look at this graph, and at what x and y values do these lines cross? And right now, I'm asking approximately. Let's just look at the graph and see sort of approximately where these two things might be intersecting, the purple line and the red line. So we're focusing on this point here in the middle. We want to know what's the x value, or what's the quantity down here, approximately, and what's the price, what's the y value over here, approximately. Well, it's somewhere in the neighborhood between 7 and 8 on the y-axis, and somewhere in the neighborhood of between 5 and 6 on the x-axis. So if I had to guess, maybe around 5.5 is the quantity, around 7.5-ish is the price. But I'm not confident that that's exactly correct. If I've drawn this really, really perfectly, which is always a doubt, it looks like that point is a little bit further to the right here on the quantity axis. Maybe a little closer to 6, and it may be a little higher on the x, but we're never going to draw things perfectly. So we're going to have to go back and look at those equations and double check to see exactly where those equations intersect. But let's write down our initial guesses here. Around 5.5 quantity, around 7.5 for the price. So in terms of complexity of math, this is probably as complex as the math gets in a typical introductory microeconomics class, solving two equations for two unknowns. But it's actually quite easy in an economics class, and here's why. If we look at our two equations, price equals 19 minus 2q, and price equals 2 plus q. If you're looking to see where those two lines cross, since these are written as something equal to price by default, if you want to see where those two equations are equal, just set the right-hand sides equal to each other. So just set 19 minus 2q equal to 2 plus q. Again, we need to do a little bit of algebra here, but it's not that difficult. So subtract 2 from both sides and we get 17. Add 2q to both sides and we're going to get 3q's. So divide both sides by 3 and we get q equals 17 over 3, or 5.66666. We can maybe round that off to 2 decimal places, around 5.67. Now we also want to know what the price is. So once we have that quantity value, 5.67, plug it into either of these two equations here, whichever one seems easier. The one that seems easiest to me is equation 2. Just add 2 to your answer. So price equals 2 plus q. The price is going to be equal to 2 plus 5.67, or about $7.67. So that's our solution. Now, it agrees with our initial guess, but our initial guess wasn't perfect, right? So it's good to be able to look at the graph and get an approximate answer, but you always need to be able to go back to the mathematics and get the precise answer. Okay, on to problem 6. Suppose in equation 1, x went from 4 to 8. What's going to happen to y? So in equation 1, x goes from 4 to 8. What happens to y? Okay, so if we go up here, well, we know that when x equals 4, from what we were looking at before, y equals 11. So let's write that down. And when x equals 8, all right, x equals 8 right over here, y equals 3. Okay, so let's write that down. What I want to do now is calculate the percentage change in x and the percentage change in y. And I'm going to review 2 formulas. One of them is actually a review. The other one is probably something you've never seen before. So let's look at your standard formula for percentage change that I am sure you have learned at some point in your schooling. The normal way to calculate a percentage change, although people will write this formula in various ways, is to take the new value of x, whatever x is that you're concerned with, and subtract the old or original value of x and divide it by the original or the old value of x, and then multiply that times 100. A little more compact way to write this is to say, well, the new minus the old value is just simply how much x has changed. So this Greek letter delta, a triangle, is a shorthand for change. So this means the change in x. And divide that by the old x times 100. I just find writing this way a little shorter and a little simpler to think about. How much did x change by? Divide it by the original number, multiply it times 100. Okay, well, let's calculate the percentage change in x and the percentage change in y using this normal method of calculating percentages. So if x is going from 4 to 8, 4 is going to be the old number, and 8 is going to be the new number, right? Because 8 is what it is now. So it goes from 4 to 8. 8 is the new number. So when something goes from 4 to 8, what is the change in that value? It went up by 4, right? Okay, so we have plus 4 divided by, what was the original value of x? Oh, well, the original value was this 4, right? Went from 4 to 8. So the change in x is going to be 4. The original value was 4. Multiply that times 100. Well, 4 over 4 is just 1. So what we're going to get is a 100 change in x. 4 over 4 times 100, we get a 100% change. Now what about y? How much is y increasing? Well, we figured out from looking at the graph, we could also use the equations that y was going from 11 to 3. So, by what percent is y going to increase? The new value is going to be the 3. The old value is the 11. If we take the new value of 3 minus the old value of 11, we get minus 8. And if we divide that by the old value, which is the 11, multiply that times 100, see what you get for a percentage change. We're going to get 72.727272. So, and it's negative though, so minus 72.72% change is what we would call that. A negative percent change just means that something decreased. It went from 11 to 3, so it went down. Now here's a new way of calculating a percentage change. And this formula is called the midpoint formula for calculating a percentage change. Economists only use this in a few specific circumstances. This kind of formula is also used in the financial world sometimes. In this course, we're going to use the midpoint formula in Chapter 6, and only in Chapter 6 when we're calculating things called elasticities. So let's look at how this midpoint formula works. It's very similar to the old formula, just one change. The midpoint formula says to take the new value of x minus the old value of x. Well, that's exactly the same way the other formula worked. The big difference is, instead of dividing it by the old value of x, we divide it by the average of the two values that we're considering. So in other words, a shorter way to write this would be on the top, how much is x changing by? And on the bottom, we just put the average of those two values. We add them up, divide them by 2. This is why we call this the midpoint formula, because the average of two numbers is the midpoint midway in between those two numbers. So let's use this formula a couple of times and get a feel for how it works. So if we're looking at the percentage change in x, we're looking at x going from 4 to 8. The change in x is going to be 4. And on the bottom, we put the average of the two values. What's the average of 4 and 8? In other words, what number is exactly halfway in between? What number is the midpoint of 4 and 8? So 4 plus 8 is 12, divided by 2 is 6. So in this case, we'd say 4 divided by 6 times 100. Using the midpoint method, we would say that this is 66.666%, or we could round that off to 66.7%. What about the change in y, going from 11 to 3? Similarly, when we go from 11 to 3, the top is the same, minus 8 is the same as doing the old method, but then on the bottom we'd put the average of those two values, 11 and 3. Add them up, you get 14, divide by 2, you get 7. So this would be minus 8 divided by 7, and we would get minus 114.3%. Let's compare the answers we get. The answers you get are going to be always a little bit different, but they'll always be the same sign, right? You're never going to have one the ordinary way telling you it was a positive and then the midpoint method telling you a negative. We're going to review this method in Chapter 6 when we get there again, but I wanted to go ahead and introduce it right now so that when we get to Chapter 6, it doesn't seem quite so strange. To help you practice on your handout, I have another set of questions that is very, very similar here. If you want to make sure you understand these, please go through this carefully and do these practice problems. Make sure you know how to do this very quickly and very accurately. If you have any questions about how any of these answers were got, please let me know. This This is Dr. Berkey signing off. I wish you the best of luck.